So now let's try to find the potential at point P. This looks very similar to a problem we did where we found the field. And in fact, we're going to again be able to find the field right at this point P right there, but it'll be a lot easier this time. So the potential, what's the potential right there? Well, again, the potential is going to be the integral of K dq over R. And check it out, R is just a constant. And it's just that. So I'm going to bring out K and R. V equals K over, what is R? R is the square root of x squared plus a squared. That is a constant. Notice I don't have to deal with this whole vector issue. This is the same distance from every dq on here, no matter where you pick it, no matter where you pick the dq, it is still that distance right here away from that point P. So V equals K over R times the integral of dq for the whole ring. Couldn't be easier. It's just our final result, we're already done, is what's the integral of dq for the whole ring? Is just charge q. So this will be kq over square root of x squared plus a squared. Now we can find the field in the x direction. What's this field here? E in the x direction. That's easy. We can just take the partial derivative with respect to x. So E in the x direction is round, it's negative, round v, round x. So we got to just take the derivative of its round x negative of, I'm going to write it like this, kq times x squared plus a squared to the negative 1/2. Take the derivative of that with respect to x. That gives you negative 1/2 times kq times x squared plus a squared to the negative 3/2. And then we got to multiply it by the correction factor using the chain rule, which is 2x. Notice how easy this was. Compared to all that vector stuff, we just simply have the 1/2 cancels that. We've got, and we can't forget our negative. I left that negative, this per true to form. I warned you not to forget the negative. I forgot it too. It's a negative, that whole thing. So we get kqx over x squared plus a squared all to the 3/2. That is exactly what we got before, but it took so much less time. We didn't have to deal with any vectors. It's a lot easier that way.